So in my open math, at the bottom of the screen, they have those videos you can click on. Now, if watching a math video isn't your cup of tea, some things you can do is, certainly ask in the discussion forum like you did, but then you got to wait for a response. So some things you can do if you go grab a PDF copy of the textbook, and then if you come to a my open math, if you haven't skimmed the chapter first, if you come to a my open math question, or if you want to do the textbook questions that you don't recognize how to do, you can skim through these examples and look at where um, something similar. And for the most part, they're here. So like here is where they talk about increasing, here's where they talk about decreasing, and they give a graph, and they talk about the answers there. And then they talk about maximums and minimums. And that's all this question is asking. So because your question that you found from Alpha Math is asking, use a graph to make the estimate, I'm not going to do the question you get in Alpha Math, but I will do for you is here on page 50 in section 1.3 in the textbook, is this question is very similar to that. This is number 41. So, and then remember, you get the answers in the back of the book, or you can go get the detailed answers. I'm not sure what the detailed answers look like with this. They might just throw a graph at you. Um, but let me show you how to do this with Desmos. Maybe you're familiar with Desmos. So I typed in the equation, and this is what the graph looks like. And then here, which one thing you can do with Desmos is make it bolder by clicking on that. And then just scroll out and see what you're seeing. Now, I see it looks like a lot's going on between, let's see, what's each line worth? 10. Looks like a lot's going on from -10 to +10, but I want to keep the y's the same. So just to help myself out, I'm going to change my x-axis scale from -10 up to +10. And it should, what happened here? I don't know what I did. Looks like I might have done 100 here. Just a minute here. Oh yeah, what happened there? Yeah, x-axis is from -10 to +10. And there we go. That time it clicked. So when a function is decreasing, as you go left to right, we almost always go left to right when we're talking about domain and range. See how the y values are decreasing? It's decreasing, 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 decreasing. So that's where the function is decreasing. And then it turns around right there at that point, and it starts increasing, 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 increasing. That's just an x-intercept. And that's another turning point. So I'm going to click on that one. I'm going to click on that turning point. I'm going to click on that turning point. So to make a long story short here, when is this function increasing? When is it decreasing? Let me get my board here. I think that's connected. Yep. So I'm going to use interval notation because often that's what my open math likes, and calculus tends what we tend to do that. So as I go left to right on this graph, it's decreasing as I go from -infinity until the x value, right? Because that's where it turns. That's where it turns. So to -3.152, and then it's increasing until this x value. So what I'm going to do is I'm going to say or actually it's increasing, then it's decreasing. So I'm going to say or use use a u, and then it's decreasing from, let's see, remember, go with the x value. So from -0.389 until +2.041, and that's decreasing because the y values are going down. Then it's increasing from that x value, the -3.152, up until that turning point, the -0.389, and then or 2.041 until +infinity. Let me undo what I just did. Undo, undo. There we go. Until +infinity. So see, the other thing I want to point out to you and make sure you see is here, where's a pointer going? See how this number, it matches up with this number? See, that's where it stops decreasing and starts increasing, and how it stops decreasing and starts increasing there, right? Now, where are we? From here to here, right? There to there, that break. Okay, and then of course, see how that number matches up with that number. So that's once you find a couple of them, it's really easy. Now, what are the maximum minimum values? Now, let's see. Let's come back and see if I can't. Those are those turning points. So this has a minimum value of negative 47.624, is 0.6, whatever that number is. And that happens at that X value. This has a maximum value right there. And then this has another minimum value there. So remember, X is where it happens. Y is what the value is. It depends what they're looking for. Okay, I think I've answered all the questions for that one out of the textbook. Let's see. I have to. I can't jump back to the software here from the screen. So let me look at my paper copy. I bought a paper copy of the textbook. Let's see. So this is section 1.3 on page 50. I said they want us to do the local extreme. I didn't talk about inflection points and estimate where the intervals increase and decreasing, concave up, concave down. I didn't do the concavity. So one of my former Oxbow students left Oxbow and went to one of those colleges down the 5 college there, down by Amherst and all that. I don't remember which one. Smith. She went to Smith, and what she learned about Smith is that she had to take calculus for poets because that was her major. Though she was a good calc student here, passed the AP calc test and everything. So her professor said, when it's concave up, it's a happy face. When it's concave down, it's frowny face. And then there's some stuff with this second derivative, but that's calculus, not here. So this is concave up. And then we kind of got to eyeball where that's happening. So, I mean, right about there. So maybe at -2 is the inflection point. So then we'd have to find the y. And maybe right about there. And this could be, might take some playing around with the math to get the exact right answer. But we can kind of click it and see. So yeah, I'm saying that inflection point is probably at -2. What is it? -2. Oops, I'm going down too far. Here, let me clean off the screen so we can see something. All drawings. So we know that inflection point's happening right about here, -2. You know, I would go with that. I would go with -2, -24 is the inflection point on that inflection point, and then it changes concavity over here also. And let's think it's 1. What if it's 1? I mean, my math isn't that creative. I'll bet I would try 1 -15 for the other inflection point. Okay. And that's how you do it. So concave up, happy face, concave down, frowny face, and you use the inflection point to talk about where it changes. So I would say concave up from -∞ until -2, and then concave up from 1 to infinity. Notice how I'm not using the y coordinates when I'm talking about concavity, but if they're asking me for the inflection point, I do need x and y. Okay, same thing with the max and min. They might say, where does the maximum minimum happen? Well, then you just care about the x. Okay, hope that helps. Give a yell if you need some more.